Have you ever stopped to think about the ice cubes in your drink? You know, how they just float? It seems so normal, right? But what if I told you that this simple little thing actually breaks a major rule of nature, and that this one weird quirk is pretty much the reason life on Earth can even exist? Today, we're going to dive into the incredible science of why ice floats.
So let's get right to it. Why does ice float? I mean, think about it. Almost every other solid thing on the planet sinks when you put it in its own liquid. It feels like it's defying physics. But the answer isn't some big, complicated cosmic rule. Nope, it's actually hidden inside the water molecule itself.
And that's exactly why we're calling this nature's coolest trick. The secret to why ice floats isn't some magic force pushing it up. It's a really peculiar, built-in property, a secret hidden right in the blueprint of water. So let's unpack it.
To really crack this case, we need to shrink down, like way, way down, all the way to the molecular level. Our main suspect, the one and only water molecule, H2O. And as you're about to see, it has a very, well, let's call it a magnetic personality.
Okay, yeah, we all know this one from school, H2O. 2 hydrogen atoms, 1 oxygen atom. Simple enough. But the real clue here isn't what it's made of. The entire mystery, the whole thing hinges on how this simple little molecule is built. The shape. The shape is everything.
So check this out. That V shape you see? That little bend isn't random at all. It is the absolute key. It shoves the positive hydrogen atoms over to one side, leaving the negative oxygen atom kind of by itself on the other. This creates what's called a polar molecule. Just think of it like a tiny superweak magnet with its own little positive and negative end. And this is the first major clue in our investigation.
And because water molecules are basically these tiny little magnets, they just can't help but be attracted to each other. This whole polarity thing leads to a really special connection. So it's time to introduce the secret force that pretty much governs everything about water, the hydrogen bond.
You see? Just like with magnets, the positive end of one water molecule is drawn to the negative end of another one. That little bit of attraction is a hydrogen bond. Now, on its own, it's incredibly weak, almost nothing. But in a single drop of water, there are literally trillions upon trillions of them, all working together to create a force that absolutely changes everything.
And here we go. This is the aha moment. On the left, in liquid water, the molecules are just this chaotic mess, a big dance party. They're tumbling all over each other, constantly making and breaking those hydrogen bonds. But when the temperature drops, that whole dance slows right down. The hydrogen bonds grab hold and they lock the molecules into place, forming this beautiful, rigid hexagonal pattern. This crystal structure, that is the key.
Okay, so the big question is, what does that rigid crystal structure have to do with floating? Well, that stunning pattern is the entire reason. It all boils down to one simple concept: density.
Let's have a quick little flashback to science class. Don't worry, this will be painless. Density is just how much stuff, that's mass, is crammed into a certain amount of space. That's volume. That's it. Just keep that little formula in your head for 3, 2, 1.
And boom, this chart shows you exactly what happens. Look at all that space between the molecules in that ice crystal. They are actually being held further apart than they were when they were all jumbled up in their liquid state. So for the exact same number of molecules, the same mass, the solid ice form takes up more space. Its volume literally gets bigger. And that, right there, is the answer. Let's go back to our formula. If you have more volume but the same amount of mass, you get a lower density. And because solid ice is now less dense than the liquid water it's in, it's buoyant, it pushes up, it floats. Mystery solved.
But hey, this isn't just some cool party trick for your glass of lemonade. The fact that ice floats has these massive, life-sustaining consequences for our entire planet. It acts like a giant, natural blanket that protects all sorts of life and even helps regulate our climate. Without it, Earth would be a totally different, and honestly, a much more empty place.
Seriously, just think about it for a second. When a lake freezes over, that layer of ice on top is like a huge blanket. It shields the water below from the super cold air. This protects the entire ecosystem down there. Fish, plants, all the other little critters, they can all survive the winter in the liquid water underneath. Now, if ice sank, like almost every other solid, lakes would freeze from the bottom up. They'd become solid blocks of ice, and life inside, yeah, it would be impossible.
And this really just drives home how weird and special water is. This expansion is the whole reason pipes can burst in the winter, or why roads get those giant potholes. That freezing water expands with incredible force.
Almost everything else in the universe gets smaller, denser, and sinks when it freezes. Water is the rebel, and for life on Earth, that is a very, very good thing.
So there you have it. A tiny little tweak in the laws of physics for just one molecule, water, makes all the difference in the world. It lets life thrive in the coldest places on the planet and shapes our world in ways we don't even think about. It really makes you wonder, right? What other simple rules are out there silently shaping our entire universe in ways we can't even imagine?